5. And number 9, we've got 1,200 square centimeters of material is available to make a box with a square base and open top. Find the largest possible volume of the box. All right, now at first glance, if you just heard me read that question out loud, you're saying, what the heck, we just did this problem? But the answer is no, we didn't quite just do this problem. There's something a little bit different about this. In this case, when we're finding the largest possible thing that we're finding is volume. And so we're actually swapping the roles from what we had before. In this case, we want to find the largest possible volume, so we want to maximize our volume. So in this problem, we want to maximize volume, and we're given a fixed surface area. On the last problem, we were given a fixed volume, and it asked to minimize or find the smallest surface area that would give us that particular volume. Okay, so we're kind of doing just the opposite of what we did before. Okay, so we want to maximize volume, and in this case, we have a box with a square base and an open top. So I can draw that box. I don't know if it's very tall or if it's very sort of short and fat, so I'm just going to draw a box. The only thing that is important is that the base of my box is a square. And that I have an open top, so I'm not including the top on this box. All right, so Andrew, this is your question. What would you like to use for labels on this box?
X and Y.
Okay. So would you like X to be the height or Y to be the height?
It doesn't matter.
You pick. It's your vote.
Base, height, whatever.
Height.
All right, so we'll let Y be the height of this box. And that means that both sides of the base will be X. Okay, and the reason both sides are X is because the box is a square base. Okay, so in terms of volume, we want to maximize volume, which means that I want to come up with a formula for volume. And volume is length times width times height on a box. So in this case, that will be X squared times Y. Now, like the last problem, we now have a formula for what we're trying to optimize. We're trying to maximize the volume, but that formula depends on two variables. So we need a relation between the two variables, the X and the Y. And so I go back over to the problem that's given to us, and the only other piece of information that we haven't used is this 1,200 square centimeters of material. And so that 1,200 square centimeters is talking about the surface area of the box. So it's saying we have 1,200 square centimeters to make the four sides and the bottom. And so 1,200 centimeters had better give us the area of the base, X squared, and the area of each side. And there are four sides, so that's 4 times XY. Okay, any questions about that relation? Okay. So once we've got this relation, then I can take this relation and solve for one of the variables. My better choice would be to solve for y because there's only one y showing up there. So I've got 1,200 minus x squared is equal to 4xy, and then I'll divide both sides by 4x. And so we've got y is equal to 1200 minus x squared over 4x. Jeff?
Couldn't we use the same relationship as volume equals W squared times L?
And so that's what we've got here.
Right,
Oh,
but I
over
mean,
here?
yeah,
Well, so the only issue about that, using the relation to volume is equal to W squared times L, is that on the last problem, we were given a fixed volume. Here, we're not
Oh.
told anything about a fixed volume. We're only
oh,
told
right,
about
that's just the, okay.
yeah. So here the fixed value is the area.
Right.
When you take the square root at the end, when you're finding, in my case, it was W, which is, your case is X.
Okay.
Since we know it's gonna be a length, it's gonna be positive.
Yes.
So can you immediately ignore the negative?
Yes.
Okay.
Yep. Okay, other questions so far? Okay, so now we've got our volume is equal to x squared times 1200 minus x squared over 4x. And we have a formula for volume all in terms of x. The battle is half won. We've done all of the setup work, and now comes the calculus. All right, so if I want to take a derivative, it's in my best interest to simplify this first. Otherwise, I'm going to have to use a product rule and then a quotient rule, and that's not going to be pretty. So, well, I guess it depends on what your opinion of pretty is. But in this case, I want to make my life easier, and so let's see, I can cancel one of the x's. And so I've got 1200x minus x cubed over 4, and then if I distribute that 4 to both terms, I've got 300x minus 1/4 x cubed. And so this is my formula for volume. Any questions on this part so far? All right. Andrew, is this how did you get into here? Or is that where you got stuck?
No. I did something completely different.
Something completely different?
Yeah, I was on YouTube and tried to look at that.
Okay.
And it took me a different direction completely.
Okay, does this seem reasonable? What's going on?
Oh,
here?
yeah.
Okay. All right, so we are totally done with the algebra now and the setup. Calculus, we want to take our derivative, set that derivative equal to 0, and solve for x. So I'm going to leave the calculus part. Are there questions on the setup before you do any of the calculus? All right, so next step. Find v prime, set v prime equal to 0, and solve for x. All right. Questions or comments? Okay. Then let's wrap up here.